Since 1953, when the Gordon Pugh fishery introduced the world to ready-to-cook frozen fish sticks, this crispy golden snack has become a household favorite. From busy weeknights to school lunches, fish sticks have solidified their place as one of the most convenient seafood dishes in the world. At the heart of this $1.9 billion industry is the Alaska pollock fishery, where high-tech factory trawlers and precision-engineered nets haul in massive catches that supply the key ingredient for fish sticks, imitation crab, and even McDonald's Filet-O-Fish. It all begins here in the Bering Sea, sitting between the rugged shores of Alaska and the vast expanse of Siberia. This frigid body of water is home to a wide variety of undersea life, including king crabs and over 400 varieties of fish like herring, cod, Pacific salmon, and more. But the catch of choice for fish sticks is Alaska pollock, a member of the cod family. These highly sought-after fish grow to be about a foot or two long, weighing between 1 and 2 pounds, and can live for up to 15 years. However, since they're a favorite meal for natural predators like seals, few ever make it to that age. Pollock mainly feed on tiny crustaceans. Despite being the most abundant fish in the Bering Sea, authorities only allow 15% of the annual pollock population to be harvested, ensuring these fish remain plentiful in our oceans. To catch the pollock, fishermen use a specialized fishing vessel like this one, specifically designed to house the ship's crew and cargo for extended periods. The vessel is over 370 feet long and more than 60 feet high, with a hull lined with steel reinforcement to withstand the harsh weather conditions of the Bering Sea. It's powered, but the magic isn't just on deck. Life on board is surprisingly comfortable, with crews spending 2 to 3 weeks at sea. The vessel offers all the comforts of home, like cozy beds, TVs, and even internet, plus a fully stocked kitchen where staff work around the clock making sure everyone is well fed for the journey ahead. Perhaps the most impressive feature of this modern fishing vessel, though, is that it's not just a boat, it's a floating factory. Stretching across 3/4 of the ship's length, this underneath facility can process up to 750 fresh pollock per minute, transforming them into packaged frozen products. This state-of-the-art processing plant gives the vessel a huge advantage. With room for up to 300 tons of additional cargo, the trawler can stay at sea longer, maximizing every moment on the water without the constant need to return to shore. This ingenious setup means crews can focus on what they do best, reeling in the fish. To haul in that impressive 300 tons of cargo, it all starts with finding the fish. That's where this acoustic echo, it's especially tuned to pick up the tiny pockets of air in a pollock swim bladder, pinpointing entire schools with incredible precision. With this tech on board, nets are cast in just the right spots, keeping the floating factory fully supplied and maximizing every minute at sea. Once the fish have been located, the crew springs into action with a procedure called the outhaul. It all starts when this deckhand attaches a strong cable and hook to the very back of the net, effectively pulling it down the stern's ramp into the water. Just as the net, with the ship cruising at about 3 knots, the natural current takes over, expanding the net into its full cone-shaped length. Before long, the net and its network of chains and cables span an impressive half-mile, perfectly set to capture schools of pollock. Fun fact: the nets used by commercial fishing trawlers are high-tech pieces of equipment that come loaded with specialized tools to streamline the process. In fact, this advanced netting rig is so cutting-edge that it can cost up to $500,000, a true testament to Next, the crew lowers the 2 outer doors into the water via chains. These heavy metal devices, attached to either side of the net's upper edge, are engineered to harness the flow of water, creating a hydrodynamic spread that keeps the net's mouth open, setting an ideal trap for any passing fish. At the same time, formidable chain weights anchor the net's base, guiding it down to a depth of roughly 5 fathoms, or 30 feet beneath the surface. Attached to the top of the net is the transducer, also known as schools of pollock steadily accumulate into the cone-shaped cod end. The opening gradually narrows, sending signals to the captain that the net is filling to capacity. When the transducer signals that the net is full, the crew springs into action to retrieve the net. During this phase, deckhands watch closely as robust chains and cables lift the outer doors from the depths, with the weight chains quickly following. Once the net is secured, the next step in processing begins, ensuring that the net begins its ascent. A deckhand carefully removes the transducer from its top. Throughout the process, the entire crew remains alert, ensuring the net stays clear of any snags or entanglements with the ship's equipment. Once the cod end, brimming with pollock, is hauled onto the deck, the next step is to unload it. A deckhand pops open a zipper at the net's end, and in an instant, the catch cascades over grates but it's not all keepers. A common side effect of net fishing is called bycatch, the term used for anything the nets haul up that isn't Alaska pollock. Over the years, fishermen have hauled in all sorts of unexpected surprises, from massive whale carcasses to, oddly enough, old washing machines lost at sea. The non-targeted species are handled carefully and returned to the sea to ensure the ocean's balance is maintained. The smaller fish slip through the openings onto one conveyor belt to be transformed into surimi, while the larger fish are guided along a different conveyor where they're precisely filleted. As the larger pollock come off the conveyor belt, they are dropped in front of a fish driver, who is tasked with making sure each fish is facing the same way on the conveyor as it passes through to the next step. Fish driving is one of the hardest jobs on the ship. From here, the fish bodies travel to this fillet machine that carries the fish along a conveyor toward 4 sequential sets of blades. The first set cuts the fish down the bottom center, then the ribs and backbone are cut out before a final set of blades removes the dorsal fin and cuts the body into 2 perfectly deboned fillets. To match the deck's impressive haul, 5 filleting machines operate concurrently, collectively process. Here, each fillet passes over a backlit conveyor belt, a method allowing workers to spot and remove any remaining bones, skin, or parasites. It's meticulous work, ensuring that every bite is perfectly safe and enjoyable. Next, the smaller boneless fillets are taken to a different machine, where they are minced, bleached, and washed in cold water. The remaining larger pollock fillets are then gathered and weighed before being tightly packed together and pressed into uniform rectangular fish blocks, ready for freezing. After shaping, the fish block boxes head into a deep freeze. Here, they're placed into this plate freezer for 2 hours and chilled to a crisp -3 degrees Fahrenheit by liquid Freon, locking in freshness as they solidify into rectangular blocks. Fun fact, rapid freezing is very important for raw seafood, as warm conditions can ramp up microbial activity and spoilage. By freezing the fish quickly, the decomposition process is effectively halted. Passes over a backlit conveyor. When the blocks are frozen solid, a crewman quickly transfers them to the next phase of processing. Next, the smaller boneless fillets are taken to a different machine, where they are minced. The fish block boxes head into a deep freeze. They're placed into this plate freezer for 2 hours and chilled to a crisp -3 degrees Fahrenheit by liquid Freon, locking in freshness as they solidify into rectangular blocks. Fun fact, rapid freezing is very important, as warm conditions can ramp the blocks out of the plate freezer onto a conveyor belt, where they move onto the next station. Next, these frozen blocks are neatly packed into boxes. Think of it like a game of Tetris, where each block fits perfectly to optimize space. Now at the packaging station, each box is carefully packed, sealed, and labeled with essential details like the product's name, its weight, and the exact date and time of packaging. This critical information ensures quality control can quickly pinpoint and address any issues that might arise with a specific batch of pollock. Impressively, this department can pack and move over 100. Once sealed, the boxes are moved along the conveyor to this cold storage hold, a giant refrigerator within the ship's hull. Here, stacked high and kept at -22 degrees Fahrenheit, the pollock awaits its journey to shore, ensuring it stays as fresh as the day it was caught. As soon as the ship reaches the port, it's time to unload. With a frozen product as volatile as fish, an army of crew members on the loading docks and the ship work together to unload the cargo as quickly as possible. In short order, the boxes of frozen Alaska pollock are transferred from the ship to refrigerated shipping containers. Now at the factory, the boxes are unloaded into even larger cold storage facilities, where they'll stay until they're ready to be distributed to supermarkets and restaurants. It's here that our journey from ocean to table comes full circle. Before the pollock can be transformed into a fish stick, it must first clear a rigorous quality check. First, a random frozen fish block is carefully selected and measured down to the millimeter, ensuring it's the perfect size for the cutting machines. Even a slight size deviation could cause jams or other hiccups that slow down production. Once the block passes the size, after approval, the factory staff quickly open the boxes and put the frozen blocks on a conveyor belt that sends them along to be cut down to size. Now on their way to being turned into their familiar fish finger shape, the frozen blocks of Alaska pollock are cut several times. An automatic band saw blade first cuts the block in half, while more band saws along the conveyor cut the halves into 9 bars each. As the blocks are whittled into smaller pieces, they're finally sent through a series of rotating blades that cut them into fish sticks. Each of these frozen block boxes, while sunflower oil has a light, neutral flavor, olive oil is richer, with hints of bitterness, fruity notes, and a slightly peppery finish. Its higher levels of monounsaturated fats and antioxidants make olive oil superior in terms of flavor and health benefits. Have you noticed the difference between these two types of oil? The extracted raw oil then passes through a fine filtration system using either paper filters or stainless steel mesh to remove any remaining particles or impurities. This ensures the final product is pure and clean, with a smooth, rich. It's all about achieving that perfect light, crispy texture that seafood lovers simply can't resist. Next, the fish sticks travel under a machine that applies the perfect amount of breading to each one. Before they move on, the batter coating they just received acts as a sort of glue to ensure the loose breadcrumb coating stays on the fish sticks. Now, the sticks travel into the deep fryer, where they're pre-fried for just 30 seconds in vegetable oil heated to about 392 degrees Fahrenheit. This brief blast of heat only crisps the outer layer just enough to lock the breading in place, making sure it doesn't rub off during transport or in the box. At the same time, this step is precisely timed to keep the inner fish frozen. If it were fully cooked, the fish would fall apart when heated at home. It's a precise balancing act, locking in a crispy golden crust while preserving the tender, flaky fish within. As soon as they have been fried, the fish sticks are immediately sent to a cooling room, where they will spend 15 minutes at -22 degrees Fahrenheit. And finally, after passing every quality check and reaching peak perfection, our fish sticks are done, ready to set sail from the factory to your dinner table. This brief blast of heat only crisps the outer layer just enough to lock the breading in place, making sure the mint has its share of environmental and safety issues too. Contamination from the firefighting foam used there has impacted local water supplies, leading to several lawsuits. The U.S. Mint Philadelphia facility failed an OSHA inspection in 2001, where it was cited for 47 safety hazards. There's also been some counterfeiting challenges in recent years. Members of Congress have criticized the U.S. Mint for failing to respond properly as the volume of Chinese counterfeit coins has increased. While the days of coins might not be limited yet, these criticisms mean that there may come a time when they will be. So look at them for now, and the bills alongside them for that matter. These aren't just units of money, they're works of art, driven in part by the elaborate ways counterfeiters try to knock them off. Bye for now. In front of you is a jar of mayonnaise. Have you ever imagined a delicious salad mixed with this rich and creamy sauce? With its mild tanginess and smooth texture, mayonnaise is a familiar condiment that almost everyone knows. But have you ever wondered how this special sauce is made? Today, we're going to dive into the fascinating world of mayonnaise production. Get ready to embark on a journey to uncover the secrets behind this beloved sauce. From ingredient selection to the production process, eggs, oil, and a touch of magic all come together to create the distinctive flavor you love. So, what's the secret to making a perfect batch of mayonnaise? Let's explore each ingredient and step of the process to better understand how this exquisite condiment comes to life. In the early 20th century, a German immigrant named Richard Helms opened a small shop in New York City. His wife, known for her excellent cooking skills, created delicious salads mixed with homemade mayonnaise. The unique flavor of this sauce quickly won over customers. As more and more people began asking if they could buy the mayonnaise separately, the Helms family decided to produce it in larger quantities. Before long, the sauce became so popular that they had to package it in small wooden containers for easier distribution. While there are many different recipes, mayonnaise always consists of two essential ingredients: eggs and oil. The process of making mayonnaise begins by blending egg yolks with oil, then adding vinegar, herbs, and seasonings to create its signature flavor. Each country has its own variation to suit local tastes. Notably, in Japan and South Korea, mayonnaise is more than just an ordinary sauce. It carries a distinct flavor that reflects the unique culinary preferences of each culture. Mayonnaise starts with eggs, specifically egg yolks, the key ingredient that creates its smooth, creamy texture thanks to natural emulsifiers. To ensure a high-quality egg supply, let's explore a 1-acre farm that houses around 20,000 hens. Every day, this farm produces approximately 18,000 eggs ready for the production process. Hens typically lay eggs at dawn, and shortly after, the eggs are automatically collected through a conveyor system. Once they reach the sorting area, they are carefully placed onto large trays using vacuum suction technology, ensuring they are neatly arranged without breaking. Each tray holds about 150 eggs, and once the sorting process is complete, the trays are carefully stacked onto carts and transported directly to the factory. When the eggs arrive at the factory, they undergo a thorough cleaning process to ensure no contaminants are present during shell separation. First, they are washed with water to remove dirt and any surface impurities. Next, the eggs pass through an ultraviolet scanning area, which eliminates harmful bacteria while also speeding up the drying process. To ensure the eggs are completely dry before the next stage, high-powered air nozzles blow away any remaining moisture. The eggs then move through a candling machine, which uses light to detect and remove defective, spoiled, or abnormal eggs. This step is crucial because even a single bad egg could compromise an entire batch during production. Mayonnaise only uses egg yolks, so the first step in production is separating the yolks from the whites. To ensure efficiency and precision, a specialized egg separating machine is used. This machine not only separates the eggs flawlessly but also prevents shell fragments from contaminating the ingredients. The egg separation process is fully automated. Each egg is placed into the system and cracked over a small funnel. At this point, the yolks and whites are separated, with the yolks collected in a designated tank for further processing. Meanwhile, the eggshells are transported via conveyor belt for disposal. Remarkably, this machine can separate up to 100,000 yolks per hour, making the production process both fast and efficient. Once separated, the yolks are transported through a pipeline system and pass through filters to remove any remaining impurities. They are then sent to a heat exchanger to prepare for mayonnaise production. After an initial heat treatment, the yolks are pumped into a large storage tank, each with a capacity of 6 tons. To help the yolks blend smoothly with other ingredients, they are gently heated and mixed with salt and enzymes. After 4 hours, the enzymes are removed as they are no longer needed. To extend the shelf life of the mayonnaise, the yolk mixture undergoes another heating process and is pasteurized to eliminate salmonella and other harmful bacteria. At the same time, a suitable amount of sugar is added to stabilize the yolk structure. Once this process is complete, the yolk mixture is cooled to 39 degrees Fahrenheit to maintain its quality and prepare for the next stages of mayonnaise production. The second key ingredient is soybean oil, which is transported in large sealed tanks by the supplier and remains unopened until it arrives at the factory. A pump transfers the oil into storage tanks for safekeeping. When it's time to move to the mayonnaise production area, the egg yolks are divided into large containers, each capable of holding about 1 ton, equivalent to 50,000 yolks. However, mayonnaise is more than just egg yolks. Other ingredients are carefully prepared to achieve its signature flavor. At this stage, water is softened for use in the formula. Then, mustard powder is introduced via a vacuum system and thoroughly mixed. Contributing to mayonnaise is distinct mild spiciness. Once the mixture reaches the desired temperature, water is pumped in to effectively absorb the mustard powder. At the same time, salt and sugar are sifted through a vibrating screen to remove clumps, ensuring a perfectly smooth texture. Mixing paddles continuously operate to blend the ingredients evenly, achieving the highest level of uniformity. In the next step, the remaining water and other dry ingredients are gradually added with continuous mixing to ensure perfect integration. To maintain the mayonnaise's stable consistency over time, a suitable amount of starch is also incorporated. The mixture is then gently heated, enhancing its creamy texture and rich flavor before entering the final refining stage. Afterward, the oil is carefully measured and slowly added to the mixture. This step is crucial because if the oil is introduced too quickly or if the mixing process isn't strong enough, the emulsion could break, resulting in a watery or separated mayonnaise. Achieving the perfect consistency requires maintaining the right balance. Too much oil can overpower the other flavors, while too little oil prevents the mixture from reaching the desired creaminess. Additionally, temperature plays a critical role in the emulsification process, helping the mixture remain stable and uniform. Once the mayonnaise reaches its ideal emulsion state, vinegar is added to enhance the flavor and activate the homogenization process. One of the key factors in this stage is lecithin, a natural emulsifier found in egg yolks. Lecithin has unique properties that attract both water and oil, binding these two elements together. As the oil combines with the egg yolks, lecithin molecules surround the oil droplets, preventing them from separating and forming a stable mixture. This mechanism gives mayonnaise its signature creamy texture while maintaining its ideal consistency without separating. This entire process is completed in just 3 minutes. In total, it takes approximately 1 hour to produce a batch of mayonnaise. Mayonnaise undergoes a rigorous quality control process to ensure consistency in flavor, texture, and nutritional composition. At regular intervals, product samples are taken and evaluated based on several key criteria to guarantee that every batch meets the highest standards. If the product passes all quality tests, it officially moves to the packaging stage. The mayonnaise is poured into glass jars using an automated bottling system. A pump transfers the mayonnaise to the filling station, where pre-sterilized jars move along a conveyor belt. Each jar is filled with a precise amount of mayonnaise according to the set standard. After filling, the jars are sealed with twist-off metal lids, preserving the product's freshness and preventing any tampering. After leaving the factory, each jar contains exactly 24 ounces of mayonnaise, and the filling process takes less than a second per jar. Once sealed, the jars move through the labeling system, completing the packaging process. After all steps are finalized, the mayonnaise is packed into boxes and shipped to stores, ready for you to enjoy on your favorite hamburger or salad. Additionally, thanks to modern customizable production lines, mayonnaise is packaged in various formats to meet different consumer needs. As you can see, this production line is filling mayonnaise into small square containers, similar to convenient mini butter packs. These small containers are not only easy to use but also fit neatly in the refrigerator, making meal preparation even more convenient for everyday cooking. Additionally, at this factory, mayonnaise is also packaged into single-use sachets, providing convenience for restaurants and food service businesses. A multifunctional packaging machine arranges the sachets in rows, precisely measuring 0.4 ounces of mayonnaise per packet before automatically sealing and cutting each one. These mayonnaise sachets are then distributed to pre-made sandwich suppliers and fast food chains, allowing customers to easily add mayonnaise to their meals quickly and conveniently. Mayonnaise can also be packaged in small plastic bottles for consumer convenience. In this process, each bottle is precisely filled with a measured amount of mayonnaise through pre-calibrated filling nozzles, ensuring it is not overfilled to prevent excessive pressure on the bottle. The bottles are then tightly sealed to keep the product fresh and safe. One interesting feature of this bottle design is that it does not have the flashy promotional labels typically found on other products. Instead, the plastic bottle has a minimalist design with only the essential product information printed at the bottom. This simple yet functional approach ensures that consumers receive all the necessary details while maintaining a clean and understated aesthetic. So, the next time you enjoy a rich, creamy sandwich or a perfectly blended salad, remember the meticulous effort and craftsmanship behind every jar of mayonnaise. From carefully selected eggs and the delicate emulsification process to rigorous quality control, every step contributes to creating the familiar sauce you love. Stay curious and continue exploring the fascinating stories behind everyday products. Thank you for joining us on this journey into the flavors and production process of mayonnaise. We hope you found these insights about this creamy, delicious sauce both interesting and informative. If you enjoyed this video, don't forget to like and share it with fellow food lovers. Subscribe to our channel so you won't miss out on more exciting content. Have a fantastic day. Deers might see sugar as the enemy, but for the rest of the world, sugar isn't just a sweet ingredient found in almost everything we eat. It's brown gold that fuels a global sugar industry. So have you ever wondered how millions of tons of sugar cane are produced every year? The journey of this humble plant begins in vast fields, where sugarcane is harvested using massive one-of-a-kind machinery. From there, those sweet, juicy stalks are transported to modern factories, where under the hands of skilled workers and cutting-edge machines, they're transformed not only into sparkling white refined sugar crystals, but every remaining part is also used to create eco-friendly products and livestock feed. Today, we'll take you inside some of the world's most advanced sugar factories and uncover the many fascinating secrets behind this incredibly versatile plant. All of that and more, right here in this video. Let's get started. Now imagine yourself standing in the middle of a sugarcane field that stretches all the way to the horizon, where towering, sturdy stalks reach up under the sun. Welcome to Brazil, the kingdom of sugarcane. Every year, this country grows over 700 million tons of sugarcane, more than anywhere else on Earth. But don't let the plant's humble appearance fool you. From this seemingly simple grass, humans have built a massive industry worth over $40 billion. And here's a sweet little fact you might not know: just 10 sugarcane stalks are enough to produce a 1 kilogram bag of sugar. Compared to other crops like corn, wheat, or fruits, which contain less than 10% sugar, sugarcane stands out with a natural sugar content of up to 16%, making it one of the sweetest and most efficient raw materials for sugar production. And it all begins with the harvest season, when the sugarcane fields come alive, ready to kick off a brand new production cycle. Before the harvest season officially begins, farmers in many sugarcane growing regions choose to burn the fields. It might sound unusual, but the goal is to remove the dry leaves and unnecessary tops of the sugarcane. This practice helps clean the stalks, reducing the amount of unwanted material like fallen leaves, organic debris, and insects, which in turn makes the harvesting process quicker and more efficient. Plus, collecting only the sugar-rich stalks helps cut down on transportation costs. However, because this method produces a significant amount of smoke and harmful emissions, sugarcane burning is now strictly regulated. In some areas where it's still allowed, burning must follow specific time frames and environmental conditions to minimize its impact on air quality and public health. In light of these concerns, harvesting fresh, unburned sugarcane using modern machinery is increasingly being encouraged and is quickly becoming the new standard. Sugarcane harvesters are engineered with high precision, capable of cutting close to the ground without damaging the roots, allowing the plant to regenerate for future harvests. As the machine moves along the rows, a system of sharp, continuously rotating blades slices the cane stalks cleanly. At the same time, the leaves and tops are removed directly on board using a smart separation system combined with powerful fans. These unwanted parts are returned to the field, thus forming a natural mulch layer that helps retain soil moisture and boosts fertility. The valuable cane stalks, rich in sugar and economic value, are pre-processed on the spot, cut into short segments, and sent to a large holding chamber at the back of the machine. A modern harvester can handle between 80 to 120 tons of sugarcane per hour, equivalent to the workload of dozens of manual laborers. This significantly speeds up the harvest process, cuts costs, and is especially well suited for large-scale sugarcane farms. Once full, the chopped cane is swiftly transferred to waiting trucks at the edge of the field, ready to be transported straight to the factory. This ensures the cane remains fresh and retains its optimal sugar content. After harvesting, millions of tons of sugar cane are transported to the factory by truck or train, depending on the region. The cane must be delivered to the mill as quickly as possible to prevent dehydration and loss of sweetness. Juice samples from different farms are collected separately and analyzed in on-site laboratories to determine the sugar content of each batch. Before processing begins, the sugarcane is passed through a high-pressure water spray system to be thoroughly washed. This step removes soil, sand, dust, and any remaining impurities clinging to the cane stalks, ensuring the raw material meets the necessary cleanliness standards. Thorough cleaning not only protects the crushing equipment from damage, but also plays a crucial role in preserving the quality of the raw sugarcane juice, the primary ingredient used to produce sugar. After being washed, the long sugarcane stalks are fed into specialized cutting machines to be chopped into smaller pieces. The stalks are cut into short segments to make them easier to feed into the crushing system. On its way to the crushing machine, each cane stalk passes through a set of interlocking metal gears that tear it apart with a processing speed of up to 30 tons an hour. This system keeps the factory buzzing nonstop. If you still can't picture how much that is, one dairy cow would need around 40 days to chew through that much sugar cane, assuming she doesn't get bored and wander off halfway through. Next, these pieces pass through powerful crushers equipped with heavy rollers that continuously press and squeeze the cane to extract raw juice. Thanks to this roller system, the sugar content is extracted as efficiently as possible, maximizing the output of the entire process. Once the crushing is done, the leftover dry pulp, known as bagas, is far from waste. Instead, it's smartly collected and reused. Meanwhile, the raw cane juice becomes the key ingredient for the next stages of refined sugar production. Have you ever experienced the scent of a mountain of sugar cane pulp filling the air? I bet it's one of the sweetest and most soothing smells that could ever make you feel truly satisfied in life. And now, prepare to be amazed by how factories make almost full use of sugarcane bagas, turning it into eco-friendly products like plates, cups, and even paper. The bagas is then collected and transported to specialized recycling facilities by truck or through a centralized transfer system. At the recycling plant, the bagas goes through a high-pressure water washing system to remove impurities like soil, sand, shredded cane peel, and any remaining sugar. After washing, it is either mechanically pressed or lightly dried to prepare it for the grinding stage. Once cleaned, the bagas is fed into grinding machines to break down its fibrous structure. The resulting mixture is then cooked at high temperatures, sometimes with a small amount of natural additives like starch or recycled paper pulp to enhance the material's stickiness and flexibility. The processed bagas pulp is poured into pre-designed heated metal molds shaped like plates, cups, bowls, or food containers. Here, the hot pressing process takes place at temperatures ranging from 160 to 200 degrees Celsius. Under the combined effect of heat and pressure, the pulp gradually hardens and takes the shape of the mold, while any remaining moisture is evaporated. As a result, the product not only forms a fixed shape but also gains a stable, firm surface ready for the next finishing steps. After molding, the semi-finished products go through a final drying stage to reduce moisture content to below 8%. Next comes the finishing stage, where excess edges are trimmed and the rims are smoothed to ensure both visual appeal and safe use. Finally, a water-resistant coating made from bio-based materials or plant-based wax is sprayed onto the surface, allowing the product to safely hold hot or liquid foods. The finished products undergo quality inspection and are then packaged using paper or cardboard materials to minimize environmental impact. From there, these bagas-based plates, cups, and containers make their way to supermarkets, food stores, or restaurants. In reality, products made from sugarcane bagas can biodegrade within 60 to 90 days and are considered a much more environmentally friendly option compared to plastic, which takes 500 to 1,000 years to decompose. Plastic is one of the biggest environmental challenges today. But the issue is, bagas products require proper industrial composting conditions to decompose that quickly. If they are thrown into regular landfills, the decomposition time can sometimes be even longer. And now, let's dive into the most anticipated part, the sugar factory, where those sweet drops of sugarcane juice are transformed into the pure white sugar crystals we use every day. After crushing, the raw sugarcane juice still contains fine impurities like fibers, dust, and organic residue. To purify it, lime is added to the juice. The lime reacts with the impurities, causing them to precipitate out, making the juice clearer, a crucial step before concentration. Next, the juice enters a multi-effect evaporation system, typically made up of 3 to 5 connected evaporators. In this system, water is gradually removed by heating the juice at temperatures ranging from 70 to 150 degrees Celsius, depending on each stage and the pressure inside. Through this process, the juice thickens and turns into a pale yellow syrup with a noticeably denser consistency. This concentrated syrup sets the stage for the crystallization step, where sweet crystals begin to form from the thick golden liquid. To begin the crystallization process, seed sugar crystals are added to the concentrated syrup, which is then slowly cooled over several hours. Sugar gradually begins to crystallize. The resulting mixture is then transferred to a centrifuge. The centrifuge spins at high speed to separate the sugar crystals from the remaining molasses. This is the key step that defines the difference between raw brown sugar and refined white sugar, a question many people have long wondered about. Brown sugar retains about 3 to 5% of natural molasses, giving it a rich brown color and a distinctive caramel-like aroma. While white sugar is refined to the point that it contains up to 99.9% pure sucrose, resulting in its bright appearance and clean, pure sweetness. After centrifugation, the sugar crystals are still slightly moist, so they are set into a drying system to remove all remaining moisture. This prevents clumping and extends shelf life. Once dried, the sugar is ready to move on to the refining stage, where it will be purified to achieve its final sparkling white form. To produce pure white sugar, a decolorization process is carried out. First, raw refined sugar is dissolved in hot water at around 80 degrees Celsius. The solution is then heated and filtered through layers of sand and gravel, followed by activated carbon columns to remove the color. Finally, the solution is centrifuged once more to obtain pure white sugar crystals. Once the pure white sugar crystals are obtained, they are cooled and fed into a fully automated packaging line within a sealed, hygienic environment. The first step is precise weighing. Electronic scales measure out exact portions based on preset weights. Next, the sugar is dispensed into preformed plastic bags. These bags are pulled continuously from large PE film rolls, cut to size, and sealed with heat. This process is incredibly fast. Dozens to hundreds of bags can be packed every minute. After sealing, the bags pass through a metal detector to ensure no foreign objects are present. Once approved, the bags are printed with expiration dates and traceability codes, then packed into large cardboard boxes for distribution to the market. They say a classic never goes out of style, and that's definitely true for the one and only Oreo. Since 1912, these little black and white cookies have been bringing smiles, and maybe a little milk mustache magic, to people of all ages. That satisfying snap, the rich chocolatey aroma, the creamy center just waiting to be savored. It's no wonder Oreos have become a worldwide phenomenon. Prepare to be amazed as we crack open the secrets behind this legendary treat. While the Oreo may seem like a timeless classic, its journey began in 1912. In 1908, Sunshine Biscuits had already launched the Hydrox cookie, a similar chocolate sandwich cookie with a vanilla cream center. Some believe the Oreo was simply Nabisco Company's answer to the Hydrox's popularity. In March 1912, the Oreo trademark was filed just weeks after its launch. Interestingly, the exact origin of the name Oreo remains a mystery. Some theories suggest it comes from the French word or, meaning gold. The original Oreo design featured a wreath surrounding the name but lacked the intricate details of the Hydrox. However, Nabisco Company's marketing prowess helped the Oreo gain traction. Over the years, the cookie saw a few name changes, from Oreo biscuit to Oreo sandwich, and finally settled on Oreo chocolate sandwich cookie in 1974, the name we know today. Despite facing competition, the Oreo continued to innovate. New flavors like double stuff and golden Oreo expanded their reach. Today, Oreos come in a mind-boggling variety of flavors catering to every taste bud. In a giant stainless steel vat, powerful industrial mixers begin by combining dry ingredients like flour, cocoa powder, and baking soda. Then sugar and vanilla extract get added to enhance the flavor. The entire mixture gets whipped around for 1 to 2 minutes until everything is evenly incorporated and forms a smooth, thick dough. Here's a fun fact. The exact amount of time for mixing might be a carefully controlled variable. Overmixing can lead to tough cookies. After the dough is all mixed up, it's time to transform it into the classic Oreo shape we all know and love. First, the dough gets fed into a large rolling machine into a uniform sheet, much like rolling out pie dough. The flattened dough sheet then meets a high-speed shaping machine. This machine uses a special mold that cuts out the individual cookie circles and presses the iconic Oreo design onto each one. Now that we have our perfectly shaped and stamped cookies, it's time for the magic of baking. A massive conveyor belt carries the trays of shaped cookies into a giant industrial oven. The oven heats up to a specific temperature, likely around 177 degrees Celsius. This allows the cookies to bake evenly, creating the crispy outer shell and soft chewy center we love in Oreos. The baking time is crucial. It literally takes around 12 minutes for the cookies to reach the perfect balance of golden brown color and completeness. They shouldn't be too dry or crumbly but should have a satisfying snap when bitten into. After their hot air bath in the oven, the baked cookies need to cool down completely. This is important for a few reasons. First, hot cookies wouldn't be able to handle the creamy filling without crumbling. Second, cooling allows the cookies to firm up and set their final texture. While the cookies take their time cooling down, let's shift our focus to the other half of the Oreo equation, the delicious creamy center. The creamy center of Oreos is made by mixing powdered sugar, shortening or vegetable oil, and vanilla extract in large vats. The powdered sugar provides sweetness, while the shortening or vegetable oil gives the filling its smooth, creamy texture. Vanilla extract is added for the classic Oreo flavor. These giant vats likely have built-in mixers that continuously stir the filling. This ensures a uniform texture throughout the entire production process, so every Oreo gets its creamy center without any inconsistency. Now that we have our cooled cookies and continuously mixed creamy center, it's time for the moment of truth, filling the cookies. The cooled cookies travel along a dedicated conveyor belt. Meanwhile, the creamy filling is piped or deposited through a series of nozzles. These nozzles move in perfect sync with the cookie conveyor. As each cookie passes by, a precise amount of filling is deposited onto the center of one of the cookie halves, like a tiny dollop gun applying just the right amount of creamy goodness. This entire filling process likely takes mere seconds per cookie. The machinery is designed for efficiency, ensuring a consistent amount of filling is added to each cookie without any mess or spills. After the sandwiching of the cookies with the cream filling, they are carefully transported on conveyor belts into a cooling tunnel. This tunnel uses controlled airflow and temperature to quickly set the cream filling, ensuring it retains its smooth and creamy texture. Once cooled, the Oreos undergo a visual inspection to ensure they meet quality standards. Each Oreo must meet specific criteria: precise cream-to-cookie ratio, a signature dark chocolate not too light or too dark, a balance of crispiness and tenderness. The cream filling must be smooth, creamy, and evenly distributed. Balance of sweet chocolatey and vanilla flavors. Wow, that's a lot of things, my friend. Oreos are sorted and rapidly packaged by machines, with a robotic arm placing them into trays for smaller packs or individually wrapping them for larger boxes. Labels with product information and vibrant graphics are applied, and the packages are placed into shipping cases for distribution, ensuring optimal freshness and reinforcing the brand's image. Oreo's parent company, Mondelez International, has implemented various environmental protection measures. The company has invested in energy-efficient equipment and technologies to achieve energy efficiency. Also, Mondelez is committed to sourcing key ingredients like cocoa, wheat, and palm oil sustainably. This includes working with suppliers who adhere to environmental and social standards, reducing deforestation,